Hi friends, myself Professor Nalin Thakur. Today we will discuss about Maxwell equation for homogeneous plasma neglecting thermal effect, and we will write it is in the form of wave propagation vector K, magnetic field vector B and electric field vector E. Now plasma itself a dielectric material. Plasma itself a dielectric material. So Maxwell equation for free space can be written like this: divergence of E equal to rho divided by epsilon 0. It is nothing but Gauss's law in dielectric theory or electrostatic theory. Gauss's law in electrostatic theory, not in dielectric theory, but Gauss's law in electrostatic theory. Okay, divergence of E equal to rho divided by epsilon 0, charge surrounding by the surface. Again, second one is for magnetic field vector, divergence of B equal to 0. That means magnetic line of force are closed. Okay, that means input flux equal to output flux. We can see here equation number 2. Third equation, Maxwell equation for free space is curl of E equal to del B by del T. Del B by del T means change in magnetic field with respect to time is equal to curl of a electric field vector. I mean rotational electric field vector. Curl means rotation. And fourth equation is for magnetic field vector is curl of B equal to mu 0 into J plus mu 0 epsilon 0 del E by del T. J is current density. Mu 0 is permeability of a free space. This one is epsilon 0 is permittivity of a free space. Okay. So we can say that curly magnetic field or rotational magnetic field can be produced with help of current density, also produced with help of change in electric field with respect to time. And this one is cause and this side is the result. This one is cause and this one is side is the result, like this. Now for plasma, we can say curl of B. For plasma, we can say current density. Plasma itself is a dielectric material. It is not vacuum. Okay. Positively charged ions and negatively charged electrons, somewhat neutral particles, like this. So for plasma, charge density is equal to rho E plus rho P. I mean free charge density plus bounded polarization charge density. Because polarization action takes place in dielectric plasma. Current density J also equal to Je plus Jp. Free current density and bounded current density. Okay. Now what is the value of Jp? Jp is rate of change of polarization vector. Jp is equal to del P by del T. Okay. Now let us place all this equation number 4. Equation number 4. We will place all this equation number 4. Okay. All this equation in equation number 4. Let us see what will happen here. So from equation number 4 we can say mu 0 J E plus mu 0 Jp, because J equal to Je plus Jp. Okay, it is like this. You can see here. J equal to Je plus Jp. Okay, J equal to Je plus Jp. Okay, we will write here J equal to Je plus Jp. Okay, and mu 0 epsilon 0 del E by del T. Mu 0 epsilon 0 del E by del T, like this. Again, let me say mu 0 is common. Okay, and Je mu 0 Je plus del E by del T, because what is the value of Jp? Del P by del T. Del P by del T. Del P, Jp equal to what? Jp equal to, you see here, Jp equal to del P by del T. So place this value. Here mu 0, mu 0, mu 0 are mu 0, mu 0 and mu 0. What is this? These are the common quantities. Okay, so mu 0 is common quantity. Je is here. Okay, Jp del P by del P. Okay, so mu 0 mu 0 is common, okay, del P by del T, and again mu 0 is common, okay, epsilon 0 into E, epsilon 0 into E, del by del T is again common like this. So this equation we can write here, curl of B equal to mu 0 in bracket JE plus del by del T P plus epsilon 0 into E. What is P plus epsilon 0 into E? It is displacement vector. Displacement vector, it is the superposition of polarization vector plus electric field vector in dielectric theory. When any dielectric material is placed under the effect of external electric field, they are produced polarization. Polarization vector plus electric field vector gives us displacement vector capital D. So curl of B equal to mu 0 in bracket JE plus del D by del T, equation number 8 we can write here, where P plus epsilon 0 into E equal to displacement vector. You know that D equal to epsilon into E in our dielectric theory. D is epsilon 0 into E in our dielectric theory like this. E is permittivity, permeability of a medium like this. And D minus P from this, D minus P, okay, equal to epsilon 0 into E. Also, from FI BSc, you know, rho P equal to minus divergence of P. Minus divergence of polarization vector equal to polarization charge density. It is from FI BSc, you know this relation very well. Okay, from all this relation, we should write here, yes. Okay, now for plasma, divergence of E equal to rho divided by epsilon 0, but here rho can be written as superposition of two charge density, rho E plus rho P. Rho E is free charge density and P is polarization charge density. P is polarization charge density like this. Okay, so let me write here, rho equal to rho E plus rho P divided by epsilon 0. Epsilon 0 into E comes here, rho E plus rho P. Okay, now delta dot epsilon 0 into E plus rho E, placing the value of rho P, I mean polarization charge density equal to minus divergence of P, what we have discussed here from FI BSc. You can see here, yes, this equation, placing the value of rho P here, minus divergence of P on this side. You can see on this side, yes. Okay, placing rho P equal to minus divergence of P. Now, divergence and divergence are common material, common thing. Okay, so del dot operator, okay, and del dot operator. What is epsilon 0 into E? Epsilon 0 into E is equal to displacement vector minus polarization vector. Epsilon 0 into E equal to epsilon 0 E equal to D minus P, displacement vector minus polarization vector. Clear? So here we should write this value, epsilon 0 into E equal to displacement vector minus polarization vector. Clear? So again, delta dot D minus delta dot P, rho E minus delta dot P, delta dot P cancel. So divergence of displacement vector equal to free charge density. It is called Maxwell's equation number 1 for plasma as a dielectric. This one is Maxwell's first equation for plasma. You can see here, this one is electric field vector, divergence of electric field vector equal to rho divided by epsilon 0 for free space, vacuum. But here for plasma as a dielectric, you can say Maxwell's first equation can be represented by delta dot D, I mean divergence D equal to rho E. This is a free charge density. Again, for magnetic field vector, plasma Maxwell equation for plasma remains same. Delta dot B equal to 0. Curl of E equal to, okay, minus del B by del T. This is Maxwell's equation number 3. And you can say, what is this? Curl of B equal to mu 0 Je plus mu 0 del D by del T. It is Maxwell's equation number 4. Maxwell's equation number 4 for plasma. You can see here. Yeah, this one is. This is Maxwell equation number 4. Curl of B equal to mu 0 Je del D by del T. Yeah, Maxwell equation number 4 for plasma. Okay. So in this way, by considering plasma as a dielectric material, okay, from Maxwell equation for vacuum, we have derived Maxwell equation for plasma, equation number 1, 2, 3 and 4, like this. For rho E plus Je equal to 0, here we are neglecting thermal effect. If you are neglecting thermal effect, rho E plus equal to Je must be equal to 0 in all this equation, like this. So this equation will be 0, okay. So this equation will be 0, this term will be 0, this term will be 0. So we can write here delta dot D equal to 0, delta dot B equal to 0, curl of E equal to 0, curl of E equal to minus del B by del T, because this term, yes, okay. And curl of B equal to mu del D by del T, mu del D by del T, because J equal to 0, So curl of B equal to mu 0 del D by del T. Now, from operator theory comparison method, K equal to twice pi by lambda. What is the unit of twice pi by lambda? Del by del X plus del by del Y plus del by del Z. I del by del X, K del by del Z, del Y. K is a propagation vector. What is propagation vector? I del by del X. K equal to twice pi by lambda. So it is a dimension of del by del X, del by del Y and del by del Z, like this. Okay. And here omega is the twice pi F. F equal to 1 upon T. It's also a dimension of time, 1 upon time. Okay. So when K tends to delta operator, then del by D operator minus del by del T operator also tends to omega. So write this relation K equal to K dot D. Means what is D? D equal to epsilon into E. Epsilon into E. Okay. Permittivity of a free space. Permittivity of a material. Okay. So K dot epsilon E equal to 0. K dot B equal to 0. K cross E equal to this operator minus del by del T equal to omega. So K cross E equal to omega B. Again K cross B. K cross B. Instead of del, we should write here K. Okay, equal to del by del T equal to minus omega. Okay. Mu 0 is there. D equal to epsilon into E. So these are the 4 equations. So in this way we can get Maxwell equation related with wave propagation vector, electric field vector and magnetic field vector by considering rho E equal to 0 and J equal to 0 with help of by considering plasma as a dielectric material. So thank you very much. You can set screenshot also for this theory. Okay. Thank you.